Hello, everyone. Thank you for joining us. I'm excited and privileged today to be joined by Simon Peyton Jones, freshly OBE, one of the key figures behind Haskell, C++, and most recently Verse. Simon and I are going to be chatting about lazy functional languages and functional languages in general, his work at Microsoft Research, and also most recently Epic Games. And also just exploring some of the lessons we can take from his career. And at the end, I know a lot of you are excited. We're going to be putting your questions to Simon as well. So, hi, Simon. Thank you for taking the time to join us. How are you?
Hi, Jeremy. Very well, thank you. It's been a happy day. But as you mentioned, this was the day in which I was actually presented with an OBE, so I'm feeling
pretty proud.
Yes, and well, and surrounded with other functional programmers, as it turns out.
So, do you want to just start off by telling everyone what an OBE is? Because there's been a lot of international viewers here who won't know.
OBE, it's a sort of British anachronism, really. It's short for Order of the British Empire, which is, I'm not very comfortable with the title. So the British Honour System just recognises people who've made contributions to society in one way or another. And in fact, the 4 other people who are receiving honours in Great St Mary's Church in Cambridge today were, had spent a long time in very local communities. There was a woman who'd spent 50 years in a local village, some 50 miles outside Cambridge, and she'd ran the Women's Institute, and she made the churchyard good, and she ran John Paul South. She'd just become an important person in that community and was being recognised today. It was great.
That's
really
lovely.
Great. Quite heartwarming.
Yeah. Somebody asks if you're now officially a higher order programmer, which I think is the first good poem of the day. Awesome. Well, congratulations. I'm glad you've had a good day to start this off. So for everyone, my side light's just gone off. Hopefully you can still see me. I'm knowing a bit darker while the camera adjusts. It is, for anyone that's not in England, the middle of the night here pretty much. It's 8:30 and the sun has long gone down. So but yeah, for anyone that's not familiar with this series of interviews, this is part of a series I've been doing since the start of the year, part of Exercisms 12 and 23, which is our challenge, encouraging you to try out 12 different programming languages throughout the year. We've had interviews with the creators of Elixir, Gleam, C++, the current lead dev Rust, head of product at Go, which I think is the only language to have a head of product. So do check those out if you've not already. But I'm really excited about this one with Simon. So the session's going to split into 2 parts. The first will be more of an interview. I'm going to explore, as I said, a bit of Simon's career, his work with functional languages, especially obviously Haskell, which I know a lot of people are excited to talk about. And then the second half will be a more of an Ask Me Anything session. So please just put any questions into either the YouTube chat or the Twitch chat. Both of those are being monitored and they'll get passed to me and I can pass them on. The earlier you ask your question, the more likely it is I'll see it and it will get answered. And also, if you do want to interject at any point during this, please just do post questions. And if they're relevant to what we're saying, I'll try and ask them then rather than waiting to the end as well. So that's the preliminaries all out of the way. So, Simon, I want to start off where it started for you, really, and discuss a little about what led up to your work that you're famous for with Haskell. How did you get into programming in the first place? What was that journey like for you?
So into programming. So I think even when I was at school, I was pretty clear that I was going to end up in computing one way or another. It was the time that the Intel 4004 was released. Intel 4004 was the first, consumer microprocessor you could actually buy. Okay. It was a 4-bit microprocessor. And the 8008, an 8-bit microprocessor, came fairly shortly after. So even while I was at school, I was, the very first computers that you could actually try out and play with yourself were becoming available. I did maths at Cambridge, which turned out to be too hard, so I switched to electrical sciences, and then I did a postgraduate year in computing, a final. So my sole formal education in computing is 1 year of postgraduate education in Cambridge. But I think I got interested in functional programming while I was at Cambridge, and like many people, the course of their lives is affected by, some significant individuals at critical moments. In my case, it was Arthur Norman, who is still active in Cambridge, actually. He was a kind of Lisp guy, and he gave a series of only, I think, 3 or 4 lectures about functional programming that was not part of the course at all. I can't quite remember how I went to them. But he explained how you could write programs without using mutation all the time. You even build strange things like doubly linked lists. I thought it was just extraordinary. How could you possibly do this? And then gradually I got more and more into functional programming and discovered that this thing that seemed impossible was not just possible, but actually a really productive way to write programs. At that stage, it was very much an academic curiosity. So Arthur Norman was very significant. And then that was while I was an undergraduate. And then around the same time, also David Turner, who I saw again today very happily. David Turner, very important person in my life. He wrote a couple of papers on so-called SK combinators, which was a kind of implementation technique for the lambda calculus that completely blew my mind. It was just like, they were very short papers, and you could systematically translate a lambda term, which was the essence of a functional program, into this mess of S's and K's, and somehow that would do the same thing. It was miraculous. So it was a bit like, the experience of, stumbling over a new set of crossword puzzles or something, which everything fit together beautifully. And so I thought, oh, functional programming, that's the thing. I better do more of that.
Yeah. So, I mean, it's interesting to think about what the ecosystem, if you like, of programming was like at the time. So, we spoke to Bjarne a couple of weeks ago, the creator of C++, and obviously that was him adding objects into C++. And at the same time, you're discovering functional programming. What was the general vibe going on at that time? Were people getting more excited about objects, or was functional programming sort of also rising?
Oh no! The mainstream was C, and BCPL was a popular language at Cambridge at the time. Also an imperative language. C++ hadn't quite been heard of. The object-oriented programming was growing. It was clearly going to be a thing.
Yeah.
But it had not yet hit the mainstream. Functional programming, very much an academic niche. Totally right. No, not comparable with all of these other sort of paradigms at all. It was just something that a few academics were studying and thought was interesting, and that was true for quite a long time thereafter.
I feel like functional programming is having its moment in many ways now. Like, we did functional February. This interview was originally intended to be in February, but it's taken us a while to get our diaries aligned. But we had that month where we were encouraging people to try functional languages, and there's clearly so much excitement right now around functional languages and around people who have maybe been brought up in a object-oriented world. I include myself in that, who are discovering functional programming for the first time. That must be really exciting to you. I'm jumping forward a lot, but yeah,
because I think of it. So I'm sort of rewriting history here, but one way I think of it is that Church and Turing were at Princeton at the same time in the late 20s, early 30s, both inventing a fundamental foundation for computation. So we had Turing machines and we had lambda calculus, right? And they didn't think of it like this, I don't think. But on the top of lambda calculus, we built functional programming. On the top of Turing machines, we built imperative programming, as it were, right? So these two things are not just different styles of programming; they're almost different ways of thinking about the act of computation at all. Though we know that they are interchangeable. We can program anything in one that we can program in the other. They're equally expressive. So then, the endeavor that I guess I started to engage in, along with many other colleagues around the world, was to say, well, if you took the functional side seriously, which at that time seemed quite ambitious, right? It seemed very academic, very impractical. Couldn't do I/O. It was really slow. It didn't seem to be useful at all. But if you just took that idea seriously, how far could you go with it? Because it's a kind of radical and elegant attack on the entire enterprise of writing programs. And so one of the joys of academia is you could actually spend time working on something, even though it seems wildly impractical. So, so then 2 decades on, we sort of start to knock down some of the obstacles that make functional programming completely impractical, like the inability to do I/O and that it's really slow. And we solve some of these things. Now, indeed, as you say, it's becomes increasingly influential. So that my slogan is, when the limestone of imperative programming has worn away, the granite of functional programming will be revealed underneath.
I like that.
So I feel it's kind of like it's a long, slow burn in which I personally think it's quite likely that functional programming will become, increasingly influential. It won't just sort of come and go. I think it's the way of the future. But I could be wrong, and I'm sure in detail I'll be wrong, and we'll learn lots more stuff in the future. But it's been an exciting trajectory, therefore, to be on. Yeah.
Yeah, massively. So tell us a little bit about it. So obviously your work, you're renowned for your work in Haskell. How did you get involved in Haskell? What were you there like on day one with Haskell? I know you're like the Glasgow Haskell compiler is your baby, if you like, but how does that fit in with the bigger ecosystem of Haskell?
Oh,
Tell us
well,
that story.
so day one was there were a bunch of people interested in lazy functional programming. So from a
Mhm,
fairly early stage, it became clear that there were strict functional languages and lazy ones. And
mhm,
initially, that was a pretty big, dividing line. And
mhm,
I was inspired by lazy functional programming, but seemed more mathematical, more functional. It was,
mhm,
strict languages tend to get side effects pretty quickly. So the
mm,
only strict, Lisp and ML existed at that time, but they
mhm,
both had side effects. So I was interested. So there was a bunch of people, maybe half a dozen research groups around the world, who were interested in lazy functional programming. And
mhm,
so Haskell started as no more than we get together at a conference and we say, look, let's just have a common syntax for the languages that we use
mhm,
so that we can swap programs, right? We have
mm,
different backends, different ways of implementing it. We're doing research, but let's just say a common syntax. So that's all it was. It was a very unambitious project to just unify syntax. We formed a committee, the Haskell committee.
right.
So Haskell is unusual in that it's not designed by an individual. It really was designed by a committee, an
Mm,
international group. And and we spent 2 or 3 years trying to, initially we thought we'll be done in 3 months.
yeah.
It took us about three years. Um,
Nice.
but then something rather unusual happened. I mean, at this stage, there was no Haskell ecosystem. There weren't any Haskell compilers.
Mhm,
There was just a bunch of researchers thinking, let's use a common,
right. Okay.
try to have a common language. But then, rather surprisingly, in the middle of this, Phil Wadler invented type classes.
Okay.
And that really had a seismic effect on Haskell. I feel it had a
Mhm,
sort of hugely influential effect on the design. So we sort of fell on type classes with joy because they solved a problem that we had been wrestling with, which is in a polymorphic language. How do you say? How can you um, add two things?
mhm,
Do we have an add for floats and an add for ints and an add for doubles? Do we have a show for ints and a show for list of ints? And too many functions. And
mm,
ML had equality types, certain kinds of type variables that admitted equality and others that didn't. This all seemed like a bit unsatisfactory. So type classes solved all of this,
mhm,
and we thought we're just going to do that. That seems like the path of the future,
okay.
as indeed it proved. So Haskell started very unambitious and then grew into a more exciting place. But even then, you used the word ecosystem. There was no such thing as an
Okay.
ecosystem. There was just a bunch of people and 2 or 3 prototype compilers and no
Yeah.
libraries.
Yeah. So how did what was your like then journey to go and build the Glasgow one? By the way, I think your mic is just rubbing slightly on your
Oh, sorry.
face. Just right, so
Right.
a bit of feedback. Thanks. Yeah. So what was your? So you then went and was it you and a few of you that went and built the Glasgow Haskell
This was a
compiler?
time at which I was at Glasgow University. So at that time,
Okay.
John Hughes, Phil Wadler, and I, and Malcolm Atkinson and Keith Van Rijsbergen were all at Glasgow University. And I joined in sort of halfway through this. They formed the functional programming group. It was incredibly effective. It was a sort of golden age of functional programming at Glasgow. It was fantastic. We just had wonderful people, lots of support from the university and the
Mhm,
department. Had an absolute wild time. So then I got a grant from the research council that essentially enabled me to build a Haskell compiler. So
yeah,
I hired a couple of postdocs, whose names you will see in GHC source code to this day. Will Partain and
mhm,
Kevin Hammond and Cordelia Hall and many others, and we built the first compiler for Haskell. While we were doing this, Lennart Augustsson was all by himself in Sweden building a compiler called HBC that we
mhm,
regarded as being, our competitor.
right.
And Paul Hudak in Yale was building another Haskell compiler, and Mark Jones built a Haskell compiler called Hugs.
Okay.
So quite a diversity to begin with.
And then from that, has that evolved where, you talked about it having committee and the language being built by committee? Has that continued all the way through today? Are features still designed or decided by committee? What's that process look like?
Well, there was a fairly long bit in the middle. You've got to remember Haskell is quite old. We were
Yeah.
talking about the Haskell committee was right back in 1990, thereabout,
Mhm,
that sort of era. And we did have a couple more iterations, went to Haskell 98. So we still had a sort of committee through the 90s. But
mhm.
then that Haskell committee more or less stopped.
Okay.
And then there was a period in which because that the Haskell language design was pretty much done, and the ecosystem was growing, and so we went on enhancing GHC, and then, but then, quite a long time later, in a fast forward about 15 years,
Mhm.
Haskell had started to become more successful.
Mhm.
So that is more widely used. And the upside of widely used, well, it's pretty obvious. The downside of widely used is people scream at you if you break their code.
Yeah.
And so we started to have to be a bit more careful about changing the language, right?
Okay.
Because the language was increasingly defined by, the compiler itself,
Mhm.
GHC. So we formed the GHC steering group, which now is a committee that reviews language design change proposals.
Mhm.
Yeah.
And there's obviously been lots of different like evolution over that, but you mentioned type classes. Obviously, Haskell's type system is at the heart of it. It's probably what it's most well known for. How has that evolved over time?
Oh, Haskell's type system has evolved massively over the
Okay,
time.
tell
Yeah.
us.
So, the built in at the ground floor, part of the
Mhm.
initial value proposition was parametric polymorphism, algebraic data types, pattern matching, all of that.
Mhm.
Then type classes made it in very early,
Okay.
and pretty early. Mark Jones taught us how to do higher kinded type variables. This is a
Mhm.
kind of underappreciated feature of Haskell. For me, it's transformative. So in a polymorphic language, you can say this function has type for all a, list of a to list of a. So a ranges over what? Well, types.
Mhm.
But in Haskell, you can say this function has type for all m and a, m of a, arrow, m of a, arrow, m of a. So what's m? M is presumably a function that takes types,
Mhm.
that's the a thing, to another type. So the kind of m is type arrow type.
Mhm.
So suddenly type variables themselves have types, which we
Mhm.
call kinds. And at first we thought, oh, you can't, because of type inference, having higher kinded type variables is out of the window. It's just too hard
Mhm.
to do type inference for. But Mark Jones showed us a very clever trick that limits expressiveness in some ways, but makes type inference a breeze. And it's worked really well in practice. So very early stage, Haskell got these higher kinded type variables, and that in turn opened up. Together with type classes, that let us talk about things like monad, right? The class monad,
Mhm.
monad of M has kind, type to type, and the class functor similarly, and applicative, and there's a whole zoo of type classes
Mhm.
that allow us to say for this kind of type variable, in this case type arrow type, there's a range of operations you can perform over it, and you just can't even say this if you don't have
Mhm.
higher kinds. So for me, that's a big thing about Haskell.
Mm.
Higher kinded type variables. All languages should have it.
Nice. Uh,
Really.
so it's sort of, I guess, maybe linked. Thinking of typing and looking at something like Elixir, where it was where Jose made the decision to make that dynamically typed, whereas
Yeah,
Haskell is obviously statically typed.
but more so.
Um,
So yeah.
yeah.
No, I have to say Haskell has a dynamic type and runtime type checking
Okay.
using statically typed type representations.
Mhm.
So you can do dynamically typed programming in Haskell too, actually.
Okay. I didn't realize.
Yeah, you
Do
can.
you, if you're writing code yourself, do you do dynamic typing, or do you do static typing? What's your like opinion, I guess, on the whole area?
So I would say, so for me, I mean, yes, for me, static typing is not just a way to avoid errors in programs.
Mhm.
As several other major features that I would find it very hard to live without. One is um, that it's a design language. So when you are writing, the first thing I do when I look at a function is say, I wonder what its type is.
Mhm.
Right. Sometimes people present code in papers, and I say, first tell me its type. Give me
Mhm.
some idea about
Mhm.
what is going on. What and the data types of your program, the algebraic data types you write down, sometimes with these higher kinded variables in them, and sometimes with fields that are themselves polymorphic functions. That tells you a lot about the
Mhm.
program. So in the 20 years ago, people often said to me, "What's the UML for
Mhm.
Haskell for functional programming?" Like UML was a thing at the time,
Yeah.
um, and my answer became, "It's the type system." Right,
Mhm.
except that rather than being a separate design language, which UML was, right,
Mhm.
it's compiled into the program and type checked every time you run it. So
Mm.
it's a design language. And the second huge thing about static typing is that it makes programs more maintainable. Right. So GHC is now a piece of code that is 30 years old, and we make repeated heart-lung transplants on it.
Okay.
And we would never be brave enough to do that if it was dynamically typed, I think, because we would not, because we're changing code that we didn't write. Often it was written by our former selves 20 years ago. We
Yeah.
don't fully understand, some of the time.
Yeah.
And I feel that large, long-lived systems, if they are purely dynamically typed, become very difficult to maintain. But
Interesting.
I'm not, you should talk to practitioners about this.
Mm-hmm.
But I suppose, in one's professional life, you have to have, a few North Stars, and
Yeah.
they're just the North Stars for me. They don't have to be the North Stars for everybody,
Mm-hmm.
but they're just static typing and purely functional programming, the things that I thought, let's just try push those ideas really hard and see how far they'll take you.
Yeah.
And I think they take you pretty far.
Yeah.
I'm happy to make the case, but I just want to make it clear that, it's not that I think everyone else is wrong. It's just that there is a really strong case to be made here.
It builds on what you're just saying on, asking a practitioner. Somebody just asked, is Haskell a language that's mainly used for researchers? They specifically asked programming language researchers, but where is that sort of line in your mind between is this an academic language? Is this a language that people are out there in the real world building
Oh
production
yeah,
systems?
totally.
I'm sure they are, but
Yeah, a lot.
how do you perceive the language yourself?
I perceive that it's completely escaped from the lab, right,
Yeah.
and
Okay.
out into into the wild. There's lots of companies that are whose typically small companies are their whole technology stack is built on Haskell. Sometimes larger companies, I know GitHub and Facebook have little Haskell sort of implants, and and banks. There's quite a lot in finance.
Yeah.
So you find little Haskell implants in banks. So Haskell has definitely escaped way out of the lab, and that's a good thing. Because it's actually it's easier if it's your whole stack. I think in very big companies, it's not, an enthusiastic team can build something quickly, and then somebody says, but we have 11 billion lines of code in PHP, and only 100,000 in Haskell. We better rewrite the Haskell in PHP, and everybody knows that it's kind of it actually makes sense in a business sense, and yet it's a tragedy from an intellectual point.
Yeah, for sure.
But so that's the only sense in which I think Haskell is limited. I do not think it's limited to the lab. I don't think of it as a research language. I think of it as a practical language for getting things done, and increasingly, so but it does come with a I wouldn't no, not a caveat, a sort of a dual purpose. So as a compiler, GHC is very consciously trying to act simultaneously as a laboratory in which to explore, interesting new ideas, and as a practical tool to get your day job done. Right. Now there is a tension there, right? Because if we are busy exploring new ideas, we might break your code, and that would not be good. So we're just trying to do extensions that don't break your code. But even then, it's difficult to be completely every time you do something new, you do the heart-lung transplant, you might break things. But we're very keen that it should continue, and I think the Haskell community is also keen that it continues this sense of innovation. The Haskell is innovating furiously all the time. So the last GADTs are now quite long in the tooth, 15 years old or something, but they were, magically innovative at the time. And, type families, very widely used nowadays in production. Interestingly, a lot of these things are used in production code because it's people in industry who are saying, I really want the types to express what I mean, because I want to be able to maintain this code. So it was somebody in GitHub who said to me, when will quantified constraints, which is another, much more recent feature, when will it land? Because we really want it.
Yeah.
Oh, okay.
Yeah.
It's good. So yes, I would say a combination of continuing fairly active innovation, but at the same time quite heavily conditioned by wanting to be, but by just realizing that a lot of people now have a pretty big investment in their existing code bases, and we should not lightly, mess with that, right? That's a challenge.
Somebody asks somebody says how do I learn the maths required to use Haskell? But and there's a broader question there of like, do you perceive Haskell as maybe a more complicated language to learn, or a language that you need a certain mathematical background for?
No, not really. I've so I'm the wrong person to ask. I perceive it as a simpler language to learn,
Okay.
right? In some ways. So I think it's a mistake to think that I think it is true to say that for somebody for whom maths has a particular appeal,
Mhm.
Haskell probably has a particular appeal as well.
Yeah.
But that's different to saying you need to be a good mathematician to understand or write
Okay.
programs in Haskell, right? So if you want to say, how does a simple Haskell program work? Well, 1 + 2, that's a simple Haskell program.
Mhm.
Let x equal 1 + 2 in x + x. That's a simple Haskell program.
Mhm.
And how do we? And then you introduce lambda. And how do you think of these programs executing? You don't imagine them with a program counter. You just say, well, we'll replace 1 + 2 with 3. We'll replace
Mhm.
let x equal 3 in x + x with 3 + 3. So you can
Mm.
think of execution as just program rewriting, and that's pretty simple. You can explain that to anybody.
Mhm.
So I mean, of course, when you get to complicated, you can write really impenetrable programs in Haskell just as
Mm.
you can in C++ or
Yeah.
indeed in C. So
Yeah.
there's no doubt about it. But I think it's not. Sorry. One other thing. I think
Mhm.
if you have spent if you have a big investment, a big existing intellectual investment in having become good at imperative and particularly object-oriented programming,
Mm.
then you have quite a lot of rewiring of your brain to do. But remember, this is going right back to the foundations of computation,
Yeah.
right? The first thing you reach for, if you're going to write a loop to add up the numbers between 1 and 10 in imperative language, you have a variable that
Mhm.
you mutate.
Mhm.
X becomes x plus I every time
Mm.
around the loop. And suddenly it's like somebody took my variables
Yeah,
away,
exactly.
right?
All my toolkit's gone. Yeah.
Yes, the very fabric out of which I used to construct computation has disappeared. Now
Mm.
that's a little bit alarming. You
Mhm.
think so then, and it seems awkward to begin with.
Mhm.
So I think there's an element of, if you're used to one way of doing things, it can be quite difficult to get really used to another.
Yeah, that makes sense.
Um,
In fact, 2 questions about IDE support for Haskell.
uh-huh.
Somebody asks, "What's the most feature-filled Haskell IDE?" Someone else asks, "When Visual Studio will get good Haskell support?" What's
Oh yeah.
the tooling infrastructure like around Haskell for those
So this is
people who
improving rapidly at the moment.
Okay.
So, Haskell's heritage has indeed been, academic and open, very much open source,
Mhm.
and very slenderly resourced. Haskell is unusual
Mhm.
among modern, let's say, widely used programming languages. If you think of Go or Swift or Clojure or Python or Perl or C++, all of them have sponsor companies,
Mm.
right?
Yeah.
They have a major sponsor of
Mhm.
some kind.
Mhm.
Rust, wildly successful of late, and Haskell doesn't.
Yeah.
The Haskell is not associated with a particular sponsor. So
Mhm.
that means that it's always been on very slender resources, which means its tooling has never been very good, right?
Mm.
Whereas F#, for example, exactly the opposite, right? It
Yeah.
started off with excellent tooling, but it was born in Microsoft, of course.
Mhm.
So um, that said, to answer your questioner's question about IDEs,
Mhm.
that really is changing now. There
Mm.
is a significant group of people working very hard
Yeah.
with support from actual companies, because they need it, on HLS, the Haskell language server. So just
Mhm.
search for HLS and you'll find a pretty good IDE. It's integrated with Visual Studio. And what's it? Visual Studio Code. That's right,
Yeah.
Microsoft sort of open source VS Code. And it does a lot already and does more with every release. It's so now for the first time, I think it's probably just the last couple of years
Mhm.
we've really got to the position where we've got a credibly useful IDE.
Yeah.
It's an
Nice.
awful lot of work building this
Yeah.
infrastructure. It
Yeah.
really
Yeah.
is. And so I think this is the first time that Haskell has been at the scale where enough people have been willing to cough up the resources to do that. So
Yeah,
it's quite
that makes
exciting.
sense. Someone says in the comments that the Haskell language server is a fantastic language server for editors that support it, like NeoVim, Emacs, VS Code. Um, they're excited about it.
I'm pleased to hear them say that, yeah, because
Yeah,
it is the only game in town. I mean, I don't think
yeah,
there's any other IDE for Haskell.
yeah, nice. Somebody else, just because you liked their first joke earlier and they've got a second, says, since Haskell takes away all of their variables, can it be considered an enemy of the state? Which took me a minute
Yes,
to get, but which I like.
there was another joke going around at the time about a separation between church and state,
Yeah, nice.
which was a reference to Alonzo Church.
Yeah, yeah, that's good. I like it. So let's pivot away from Haskell a second and look at C minus minus. I don't know if I'm
Yes.
saying that correctly. So I know nothing about C minus minus. I'll be totally frank. But I presume it's some sort of counterbalance to C++, just by the name.
No.
No. Okay, good. I'll stop guessing. You tell me.
So C minus minus was we had this compiler for Haskell, and we
Okay.
wanted to have multiple backends for different backends. So what are we going to do? So we compile that, lambda calculus, SDG machine, but then we wanted to get to some more a machine that's closer to the metal, a machine that had calls and program counters and stacks and so forth. But still wasn't x86 machine code or 68,000 machine code. So C minus and for some while we were using C for that purpose. Right, so we compiled into C and then compiled C for different platforms. But C is not designed as a compiler target language. You have to really bend over backwards to make it work like that, and it's difficult to make it work really fast. So C minus minus was meant to fill that slot. Was meant to be a machine, a platform independent compiler target language. That is the thing into which compilers could compile, could then compile for multiple backends. The challenge is, this has been attempted many times, right?
Yeah.
So this was Norman Ramsey and I were working on this C minus minus thing. We thought rather than just doing something ad hoc for Haskell, let's try to define something that other people might use, so that the backends we build might be useful for other things. The tricky bits are to do with how do you manage the garbage collector. Right, because then the garbage collector has to walk the stack. The stack might be living in and how do you manage having millions of stacks? Because Haskell already had very lightweight concurrency, so stacks have to be heap allocated objects which themselves can move around and certainly contain pointers. So the garbage collector needs to walk over them. So you need to have a pretty intimate interaction between the thing that's compiling this machine code stuff and the garbage collectors. That's quite tricky to arrange. Exception handling is another thing. So Norman and I wrote had several papers about this and built a sort of something. But then in fact LLVM won.
Yeah, right? I was going to say that's
LLVM was not a thing when we started. But Chris Latner and his colleagues caught the wave and they just caught fire in a way that C minus minus hadn't, and thumbs up for that. GHC compiles through LLVM now. It saves us a lot of work, right? Because that's one ecosystem we didn't have to build.
Nice. So do you have any C minus minus code still in there, or is it all been replaced?
Yeah, so internally within GHC, there's a data type called C minus minus.
Right.
And it does have a concrete syntax, but bits of the runtime system are written in that language. But we no longer aspire to make it, a general purpose compiler backend language. It's just an intermediate data type that GHC uses before it gets to LLVM.
Nice. Yeah. Okay, so everything's going through LLVM now. Yeah.
Not everything, in fact, because going through LLVM itself is a pretty big hammer, right? So if you want to just compile fast, use one of our native code generators.
Right. Okay.
Right? Which they don't generate as good code as LLVM, but they generate a lot more quickly.
Yeah. It's been interesting discussing this, like, with the different people that have created languages, and this sort of decision is such a crucial part. Like thinking of the stack that everything's running on, obviously, like with Elixir and Gleam and stuff running on Beam, and just it feels like there's so many trade-offs and things to think about in this stage. And again, especially if you're going back 20, 30 years before so much of this modern tooling was there, like you had to invent the wheel because it's somebody asked.
So the other thing, WebAssembly is now the other player in this space, right? So it too aspires to be a common intermediate language for compiler target language. So it's like I was saying, we were compiling to C and it's not very satisfactory. Let's design something with the purpose. Right? A lot of people compiling to JavaScript, which is not designed as compiler target language, and WebAssembly is meant to be there for the purpose. And in fact, yes, GHC will compile to JavaScript. And there's a WebAssembly backend for GHC that's coming along really fast now. So there's sort of the two big portable platforms are now WebAssembly and LLVM. Yeah.
Nice. I was going to ask about this because we have in Exercism we have 65 languages we teach, and for every one of them we maintain a production set of tooling in that language. So we have our Haskell tooling that sits there that runs on servers that does stuff. Yeah. And obviously for us, not only is that a lot of code to manage, but also a lot of code to be running on servers and handling, and it's a lot of pain for 3 technical people in a team and a lot of volunteers.
Yeah, I think that's amazing. You maintain 60 implementations. Wow.
Yeah, it's crazy. But obviously WebAssembly is a really interesting approach to that for us, because then that takes away a lot of the hosting pain and the cost. So it's been really exciting to me over the last, every month there seems to be evolution, but to see that a lot of languages are getting closer to the point where you feel they could be production run in WebAssembly now. Is Haskell is it already at that stage? Is it getting to that stage?
No, I think where there's a team, again, a commercially funded team now working
Nice.
on the WebAssembly backend for GHC, and they're making, they're at the stage when they can run our whole regression suite without
Okay.
and the only failures are kind of irritating, strange IO library mismatch kind of
Okay. Yeah.
failures rather than fundamental ones. So that's pretty impressive. So we really are getting there. But the thing about the garbage collecting thing I was just wanting to mention is that,
Yeah.
that WebAssembly has all of this, all of this question all over again.
Yeah. Of
So our
course.
initial backend, we just compiled to WebAssembly and have GHC's existing runtime system and its garbage collector
Mm-hmm.
all compiled from C to WebAssembly. So in effect, if you're going to run GHC compiled code in WASM, then
Mm-hmm.
you're running GHC's runtime system
Nice.
completely,
Yeah.
right? Not so nice in a way because
Yeah.
you're in a web browser which already has a garbage collector.
Yeah.
Right? A
Okay.
pretty good one, actually.
Mm.
Why do we implement some multiple garbage collectors? So wouldn't it be cool if we could all compile to a backend that was built on the substrate of an existing memory management system, really well implemented by with thousands of man years of effort? These are astonishing achievements. These runtimes in web browser. Well, it turns out it's quite difficult. This is what
Mm-hmm.
Andreas Rosberg and others are working on pretty hard at the moment. Is trying to think, how can you make something that's reason that you could reasonably compile Haskell and ML and Java and other things all to,
Mm.
without
Somebody asked,
messing
could
about.
you transpile Haskell to Rust to avoid the garbage collector?
No, I think it would be hard to avoid the need for garbage collection in Haskell.
Yeah.
Yeah.
Yeah. It must be
So I
nice
think
for you
in the
to have.
reverse direction, I was speaking to a colleague today who was saying, well, we increasingly see, he's a researcher, he says we increasingly see well-typed, well-written, well-typed Rust programs are
Mm-hmm.
essentially functional programs in disguise,
Yeah.
just ones that don't need a garbage collector.
Mm-hmm.
But the reverse is tricky, right? So you could almost imagine converting Rust into a functional program, but not
Yeah.
the other way. The storage management thing is a big deal, and that is, of course, Rust's win too.
Mm-hmm.
Right? Doesn't need a garbage collector.
Yeah.
But I do think people sometimes underestimate just how good today's garbage collectors are.
Mm.
They really are pretty amazing pieces of kit.
Yeah.
And you no longer get long, embarrassing pauses. GHC and OCaml and all these things have incremental garbage collectors that work really pretty well.
Nice.
I don't think there's anybody I know who's really for whom anybody in production
Mm-hmm.
for whom GC is actually their problem. Space
No.
leaks, yes, but
Yeah.
not storage management.
Yeah. Yeah, when I was chatting to Josh Triplett, who's lead dev at Rust, or one of the lead devs at Rust, he was talking about how he has a real love of functional programming that came from Haskell, and if he writes Rust programs, they're always very functional. That's how he approaches these things. So yeah, it's interesting to see that. There's a few questions about your opinions of lots of other languages. I maybe leave that to the end, and I don't necessarily want to put you on the spot by asking that, but just carrying on the journey of your career for a moment, because it's fascinating. So one of the things I really found interesting was reading about the fact that you did loads of work on Excel and on functions in Excel. And I guess it's funny, isn't it? You can use a program like Excel for your whole life, and you never really think, well, when I'm typing a function into a cell, what's going on there? But I guess that is a programming language in many ways, and definitely the stuff happening under the hood. So I guess I had two questions. One, what was it like working on Excel? Like, I mean, I'm just intrigued. But two, what's actually happening under the hood in there when I, run a function in Excel? What programming language is getting executed underneath? What's that look like?
Well, it was quite a lovely story, really. I started to work at Microsoft Research, and I thought in 1998 or 99, late 98, I think. And I thought, what's a functional programmer working for Microsoft going to do? So I was in a research thing, so I could do more or less what I like. But I thought, well, where is functional programming being used in Microsoft? Aha! Excel, the most widely used most widely used programming language in the world, let alone functional. So, in fact, the most widely used programming language in the world is actually a functional one. As you say, people use it without even knowing. They don't want to say equals 1 plus print x or 1 plus x becomes x plus 1. It would be stupid. It just doesn't make sense in that paradigm. So we are all functional programmers, really. And so then I thought, well, so then I started visiting the Excel team who were in Redmond, and they were very friendly. They would entertain me, and we would have lots of beers, and I would explain that I thought that Excel was a great functional language, but far too weak, right?
Mm.
It was a functional language in which you could not define functions.
Yeah.
They give you 600 functions built in, but that's
Mm.
it. You
Mm.
cannot define new functions. Oh,
Mhm.
except you can define a new function if you're prepared to write it in Visual Basic.
Yeah.
I mean, that's like bonkers. Can you imagine a C with no ability to write new functions? Very good copy paste, like clever copy paste that enables you to copy the code for one thing and splice it in somewhere else, changing the names of the variables. But the only way you could write a new function in C would be if you wrote it in machine code.
Yeah.
I mean, it'd be
Yeah.
nuts.
Yeah.
So I was saying it's completely bonkers, guys. If we just give our users the ability to define new functions in Excel itself,
Mm-hmm.
then they will be able to build functions that call functions that call
Mm-hmm.
functions that call functions, and there is no limit to the complexity or
Mm.
ambition of what we can build, because we know that functional programming is actually Turing complete.
Mm-hmm.
So so the functions were one part of it. Data was the other part, that you could only manipulate scalars in Excel. It has some
Mm-hmm.
limited ability to manipulate arrays, but pretty limited. It had no notion of arrays as first-class values, true first-class values that could be stored in a cell, returned from a function, the arrays with arrays as elements, all of that. No, so these were simple, very simple ideas from functional programming. So, and the Excel team, they thought this was extremely good idea.
Yeah.
And so I would talk to them, and then a few months later, they would phone me up and say, "Sam, I'm really sorry, but all of our cycles are going to get taken up in this iteration of Excel, get taken up on, moving to 64-bit,
Right.
or
Okay.
to, or to concurrent editing, on the web or something.
Mm-hmm.
There was always something else,
Mm-hmm.
a good business reason why none of this was going. So I got a bit discouraged by this.
Mm-hmm.
So I sort of left them alone for about
Mm-hmm.
10 years, actually. And then
Wow.
about 2015 or so, maybe a little earlier, my boss at Microsoft said to me, "Why don't you go back to those Excel people and see, because that seemed quite successful at the time." So I did. And interestingly enough, one of the people that I'd been talking to, a chap called Dave Gaynor, who
Mm-hmm.
was at that stage an ordinary program manager, leaf
Mm-hmm.
of the tree, he'd become the big boss.
Wow.
Um,
Nice.
so, hang on. Oh, hang on. That's
That's
my
fine.
daughter. Hang on. I'm going to get. Yeah, my daughter's home for scouts, and it's only going to take me 10 seconds to get her in.
So one of the reasons that we are doing this at 8:30 in the evening is that Simon wanted to do some kids' bedtimes and things before he came and joined us.
So it was a very unusual a technology transfer strategy. Is
Yeah.
wait till somebody who you've been talking to 10 years ago becomes the boss. And Dave said, "Oh yeah, we should definitely do this."
Nice.
And even then, the other sort of lesson that might be interesting for people listening to this is that industrial software at scale is very ponderous. It takes a long time to get anything done with Excel, because it is a huge monster.
Mm-hmm.
In multiple languages, you've got to be terribly careful not to break anything ever.
Mm-hmm.
So it is extremely onerous to change Excel. But nevertheless, Excel now does have fully first-class lambda, in the sense that Alonzo Church defined it. Right?
Nice.
So it is a Turing complete language now. And it's going to get much more about, going to get more. This trajectory, I think, is going to continue. So I'm quite excited. That may turn out ultimately, it's been a bit of a slow burn, may turn out ultimately to be more impactful than anything else I've done. I have no idea. But I think getting Lambda into Excel is a big deal.
Yeah.
And if anybody listening to this doesn't know about Lambda and Excel, just sort of grep for that and have a look and start writing, serious functional programs in Excel. Oh, you asked, what did you ask? What happens under the hood?
Yeah.
Excel expressions get compiled to a sort of bytecode. They're sort of serialized, and then the bytecode is executed pretty directly by a kind of in a bytecode interpreter kind of thing.
Okay.
The bytecode is absolutely round trippable back to source code.
Okay. Nice.
So it's not really a compiler. It's just a serialized form that's good for execution.
Fascinating. There's so much stuff in the world like that you just have no idea about, and that you just like blindly use, and then one day it's like a little light bulb goes up in your head and you're like, hold on, there must be something happening here. It's
I think Excel is because it's so intuitive and appealing, and you don't have to apologize for functional programming. You don't have to rewire your brain. I think this is, if we could, I'd love to see us teaching, a child's first programming language is Excel, right? And so their first real experience of programming can be a purely functional one. right?
So
Programs.
as many people watching this will know, we're building out our own learn to code platform, and we spent 2 months really in January and February just making a lot of decisions about that. And Eric, who is the head of open source at Exercism, one of the 3 full-time devs there, he's a big polyglot, so he's written a lot of the tooling in all 65 of the languages or contributed. But so he's got a very wide scope of things, but he's a big C++ developer and lots of other things. But when we sat down and we thought, what if we wanted to teach somebody programming from scratch, how would we teach it?
Yeah.
We all came to the conclusion that functional programming would be the right way to do it. From just, as you say, that conceptual model of how things sit, it just feels like it makes sense as building blocks that you can just build your knowledge and your thinking on in a way that I feel like if you're learning other paradigms, you have to mutate your brain almost to be able to learn mutation. Like, you don't need to do that so much if you're starting from zero with functional programming.
The one thing it does, the one place that imperative programming really does shine, though, is that if you teach, my son, who's 11 now, has been doing quite a lot of Scratch. And that's a very imperative programming environment, right? But it's very it's very visceral. You change a variable and you see something change on the screen. So there's a very close connection between computation and visualization, and that is very appealing. Very appealing.
100%. I think and this was something we were wrestling with, because one of the things that we're aiming for with this is like live execution of code. So as you're changing the code, immediately whatever you're changing is appearing on the side. And we came to the conclusion you need quite a lot of like functions that you can call out that are going to be causing that thing to immediately change on the screen. It's like you have to build a whole IDE around that concept. And I know Scratch is a whole IDE effectively, but
in the functional programming world, you should check out things like make sure you check out Racket and but that's a very sophisticated interactive programming environment for the Scheme language. Chris Smith's Math World, and there was one other I was thinking, but that would come back to me.
There's I think with Clojure as well, there's some really, really good stuff around Clojure, interactive stuff in there. I've not tried it, but I've heard. So
Bootstrap World.
Oh yeah,
There's a whole educationally focused project using Scheme, but with pretty good ID and visualization to go alongside. Yeah.
Nice. I'm going to definitely pick your brains.
So you don't want to reinvent the wheel here.
No. Oh, 100%.
You want to build on the best that you can find.
Yeah.
Yeah.
There is a question that somebody asked: is should everyone be inventing their own programming languages? I think you just answered that one. So we can.
Yeah.
What do you think?
So Fred Brooks put it rather well. He said, in computer science, unlike in natural science, novelty is of no merit on its own, right? That is to say, anybody can invent a new programming language, right? It's not a thing, right? No. It's computer science like a fractal subject, whereas not anybody can discover a new feature about electrons, right? That's a fact about the physical world. So natural scientists, something new is important in and of itself, not in computer science. So it must have utility. So then you've got to say, why would you, why would you design a new language? Well, as an intellectual exploration, definitely, just go for it, right? But then sometimes you get lucky. It's really it's good for languages to be born and die quickly, right? Because they don't consume too many resources, or else to become successful. Some languages become successful very quickly, like Rust or Python. Others die quickly. Haskell has been very unusual in slowly gaining more traction over time. That's a very unusual trajectory.
Interesting.
Right? Mostly they gain traction, then drop off a cliff, or go into the stratosphere and stay there because there's so much code nobody can drop them.
And what's caused that? Is it because it's been used consistently by a small group of people and now it's like almost intertwined with the rise of functional programming, or the other variables in there, do you think, for that?
Why is Haskell? Well, so I would say that probably OCaml is on a similar trajectory. Right? So maybe it's because we're just riding the granite is being exposed wave functional programming, right? And by sticking the reason with the rise was not sharp is because well, there were lots of things not to like. Couldn't do IO, it was really slow and so forth. So we knocked these some of these barriers down, and then there's still obstacles like not enough of our staff know how to use it, and so So it's never. But in some ways, I think it's great that Haskell has not succeeded, in going mainstream too quickly, right? Because it's enabled us to innovate, right? If Java went from zero. Java is a much more a younger language than Haskell. It was born way after, well, at least 6 or 7 years after Haskell, but it rapidly went into the stratosphere, became the purview of standardization committees. It was very difficult to innovate in after that. So Haskell has had this lovely, slow burn trajectory with bags of innovation along the way. That's a
so
exciting.
I think this segues nicely into your decision to build a verse, which is your new programming language. So what's the what's the rationale behind that? What are you trying to achieve with it? Presume no one here knows what verse is.
Right. Yes. So Verse is not my decision to build Verse.
Okay.
So Verse is very much Tim Sweeney's baby. So Tim Sweeney is the chief executive and founder of Epic Games, and he is the original author of the Unreal engine, which is a immersive virtual reality engine that's the foundation for all of Epic's games, and indeed foundation for sort of metaverse-like ambitions, and also for things like architecture and manufacturing and design. Unreal is used for a lot of things. The film industry, great deal. So Tim wrote the initial. He is a virtuoso C++ programmer. Absolute virtuoso, and he's a sort of uber geek. He's a really nice guy, extremely smart. But he somehow has managed to create a very successful billion-dollar company as well. So I think of it as it's like Bill Gates. There aren't many of these people. So, but he's for the last 20 years, then he has been, building Epic as a company and developing Unreal. But he's had a sub-process working in the back of his mind the whole time for 2 decades on what is the right programming language to program all this stuff in. Right. And he has emerged with some quite, some unusual and, really actually rather intriguing and interesting ideas for how to design a programming language. So the way he puts it to me, Simon, he says it's an opportunity. We need something to live between Blueprints, which is a very visual programming language for Unreal, and C++ at the bottom. So we need something in the middle. So and Verse is that language in the middle. So so my job now actually is to figure out what Verse is. Right? Because Tim has this pretty well conceived idea of what it is, but getting it out of his brain and onto paper, in a way that could be understood, have a formal semantics, for example, because if you're going to build a compiler for something, you better know what programs mean. So along with Leonard Augustin and Ranjit Java and Stephanie Wyrick and Olin Shivers and a bunch of other people, Kuhn Klassen, we're busy trying to figure out what Verse is. And that turns out is quite an interesting research project, because Verse is in fact a functional logic language. So if you think of the whole spectrum of programming languages like this, then functional languages are a sort of let's say a little something of a niche over here, right? Growing niche, influential niche, as we've been discussing. Functional logic programming, little niche within the niche. But and just as I've been saying, I think that functional programming is a better way to write programs. Tim would say functional logic programming is a better way to write programs. So our goal is to kick functional logic out of the university ghetto and into if not the mainstream, then at least the metaversey gaming mainstream. And so that means we have to understand what functional logic programming is, right? So I'm busy, with these other colleagues writing papers about it, trying to write denotational semantics, trying to rewrite rules, trying to lay the foundations. It's a big research project at the same time as we're trying to actually build and ship earlier versions of the language. It's quite an ambitious game.
So is it a language that how widespread is it intended to be? Is it going to be just for people who are building on Unreal Engine, or is it just going to be a general programming language that is it compiled to C++? Like, is that it?
At the moment, it will start life definitely as this is in fact the initial release was only a couple of weeks ago for Betaverse, I think it's called, which and that's and that is in the context of what's it, UEFN, Unreal Editor for Fortnite. So it's the way in which you can give behavior to characters and machines
Hmm.
and bits of your game in a sort of not Fortnite the battle game, but Fortnite the virtual environment.
Yeah.
So that's the way it'll start. But Tim definitely sees Verse as a general purpose programming language, and we will, in due course, ship standalone Verse compilers.
Hmm.
And he's also Tim is great. He's a very open source guy. He says we'll ship these compilers in open source form. We'll work with open standards and all
Nice.
this metaverse stuff. He wants to be very open standardy. So
Hmm.
so when we're submitting papers to conferences because we want to publish this stuff. It's not a secret. So that's really really good.
Nice.
Yeah. And there are other things about Verse. What it'll take transactions very seriously. This
Okay.
is software transactional memory kind of transactions. But
Hmm.
if you've got a game with lots of characters all doing things to each other, and they're written by different people on different continents, but they've all got to interact together in this metaversey-like environment, then somehow they've got to coordinate their activity. And software transactional memory seems to be a good way to do that. So,
Okay.
but rather than just doing it within a single processor, we're going to do sort of STM or something very STM-like across a data center scale. That's pretty ambitious too.
Yeah, yeah.
So there's lots of ambitious things about Verse.
Nice. Somebody asks, I don't know what this means, so you'll forgive me, but they're interested in your opinion on Adersky's idea of expressing effects with delimited continuations, which seems like close to Verse's take on things.
Oh, I'm not sure I'd have said it was closely connected to Verse. I mean, delimited connect. Once you get the hang of delimited continuations, you see them everywhere.
Okay, can you explain what they are?
Threads. So imagine that you have the stack of a running process,
Yep.
right? Then if you as it were, just took a copy of that stack and put it on one side, then you carried on this one, the one you were starting with, and then you went back to this one over again, but started again from for this stack. It has a program counter and everything, but maybe you give it a new input, right? Because you were just about to return from a function on that stack, so now you return with a different value.
Yeah.
Well, it would evolve in a different way. So this saved stack, that's a continuation.
Okay,
Right?
I see.
That's what a continuation. It says, so I've got a computation which I'm going to continue, but I'll sort of capture the continuation by, as it were, making a copy of the stack. The implementation technique may vary, but that's the idea.
Yeah.
Right? Now then, another thing you might do is not copy an entire stack all the way to the base, but copy just part of a stack. Right? That's a delimited continuation.
Right.
Right, and it's it lets you do sort of resumable things where you say I want to do something, then resume this computation later. Like if you wanted to build a multi-threading system with lightweight threads, in Scheme you would use delimited continuations to do that, but it has delimited continuations directly to capture the stacks of the little lightweight threads that are sort of being arrested and are going to be resumed later. So, how does all this connect to Verse? Not. Yeah, I wouldn't have thought of them in the same breath.
Okay. Perfectly good answer to the question.
Yeah.
So I had a question about how you see the future of functional programming evolving. Is it in functional logic? Is that languages? Is that where you're imagining functional programming in general goes? Are there particular questions in functional programming that you feel haven't yet been answered, or things that you think will change about functional programming moving forward? Or do you feel like, I was about to say we've taken it, but you've taken it with your colleagues to a certain place now that it's not complete, but it's got to a stage where, I'm interested in just that whole area.
So, when we start, when I was at the beginning of the journey that we've been discussing, I think functional programming was an experiment, right? It would say what would happen if we took this idea of programming without side effects, purely functional programming? Could we make that real? So I think the answer to that question is now clearly yes.
Okay.
Right. So for functional logic programming, right, I think that we're at an earlier stage in that trajectory. Is it going to be, are we going to look back in 20 years' time and say, now that has had a big effect on our community? I don't know, but just like me back in 1986, I was thinking this is really cool and interesting and definitely worth a go, right? So then your question was what? So what's next?
Yeah, what's next? Either for functional programming, like, do you feel like, are there other problems that people are out there trying to solve, around functional programming? I guess you talked, at the beginning there were things like the IO constraints and these things, which were like, I guess, the barriers to more and more mainstream adoption. Do you feel like there are still barriers that need to be solved, or do you feel like that's reached that sort of pinnacle?
I think there's lots of, nitty-gritty engineering things that still need to be solved. GHC compiles too slowly, for example.
Okay.
But that's not the kind of principled thing that you're really after here. I think we're still one of the places where I feel we're still experimenting and exploring is to try to find out what's we were talking earlier about static types, right? So static types are the world's most widely used formal method, right? That is if you use a statically typed language, you are using a formal method. There is a theorem prover involved. It's called the type checker, and you run it every time you run your program. Now, Haskell's type system has got more and more sophisticated over time. Partly because we can, and it's interesting to explore that kind of thing, but also partly because that people say, well, look, I want to be able to say this with my types. I want to be able to express in the types what's in my head. I don't want to leave it in my head. I want to articulate it in the types, and then it becomes part of the code that really is checked. So, but of course, as it becomes more sophisticated, it also becomes more complicated. It can express more, but it's also harder to think about. And does this program type check becomes a question that's more difficult to answer. So at some point we'll experience some kind of heat death at which the type system becomes so complicated that nobody can figure it out anymore, right? And so that's one boundary. What's a good place for the type system to end up? But another boundary is that I think we're going to do increasing amounts of, I'll call it lightweight program verification, right? So when the type system is sort of part of your source code, but I think we're going to do, you might also want to have properties of your program that say, quick check is very good at this. You can say this, this function never returns the empty list, for example, or these two lists are always the same length. GHC itself is littered with assertions of these kinds.
Right. Okay.
Say, in your code, you know that this situation can never arise, but the type system isn't clever enough to express that, and maybe it'd be too hard to express it. So then we want to have, verification techniques, and that means sort of external theorem provers that help us reassure us about these. And I think they're the field's wide open. Liquid Haskell is my favorite poster child for this. Ranjit Jala and Nikki Vazu and colleagues have this amazing theorem prover attached to actual production Haskell, not just a toy prototype that lets you do some of this kind of reasoning. And I think that's got a way to go yet. I don't think it's not really production ready. I think it's usable if you know what you're doing, but at scale, I think we've got more development to do. But I think it's very promising direction. So those are the kind of areas I think we're going to explore.
I feel like there's almost like two different directions that I can see happening. There's the things you just said, which dealing with those meaty functional problems. Which was the answer to the question. But there's also then this plethora of other functional languages that are, I want to say, maybe more approachable or more accessible for another developer. Elixir, I think, is a massive one that's just really easy and joyful to work in, that has caught people's imaginations. We talked to Louis, who's built Gleam, which is really at the early days, but still a lot of people are really enjoying it. And it feels like there's that's helping functional programming become more mainstream. Do you imagine things like Elixir are almost a bit like a gateway drug into Haskell? Do you imagine the more, as people discover the joys of functional programming through Elixir, do you see them then migrating on to Haskell? Do you imagine that?
I don't know. I think all this diversity is really good. Elm is another example.
Elm's a
great language inspired by Haskell that's been really quite successful. And their successes are our successes, as it were, as a community. But I don't think if you're happy writing Elixir, stay happy, right?
Okay,
maybe I'm not an expert of Elixir, but maybe for for the thing that you want to do, it may actually be better. Maybe sort of lighter weight to get the job done more quickly, or just be more approachable or something. Haskell is a bit of a behemoth now. Right? Compiler's quite heavyweight, and the binaries compiled to quite big. The libraries are very large, and so forth. But I suppose that in a while, maybe somebody will come along with a language that just Haskell's also quite complicated. I mean, that's partly deliberately, right? So we explicitly not tried to say, look, that's quite similar to something we've already got, and we don't want to have too many ways of doing things. We wanted Haskell to be a laboratory in which we explore new ideas. And that means that there's quite a bit of diversity and overlap of features and so forth. So maybe somebody will come along with a clear-eyed vision and say, oh, we can simplify a lot of stuff and have a language that is conceptually more straightforward, but to sort of essentially beat Haskell at its own game, and that would be great, I think. But I don't know how to do that yet, and I'm waiting for some smart person to come along and do it. And until then, I'll try
you just keep inspiring the field. Somebody says, Haskell is so complicated, especially obviously its type system. How has it managed to stay relatively fast to compile? And I know you said that you feel like it's slow to compile, but with so much complexity around that type system, it seems impressive that it has become that fast.
Well, and so the compiled code itself runs reasonably fast. Well, the compiler is slower than I would like, though we make intense effort. This is another, sea change. Nowadays, we don't. Every merge request comes with performance bounds. And if it makes the compiler run more slowly, we look very carefully at it before we allow it through. But I think one thing that I'm actually quite proud of about GHC, the compiler of Haskell, is it takes this enormously complicated language, in effect, and compiles it through a tiny little toothpaste tube called the lambda calculus.
Right.
So, and the GHC's intermediate language is really System F, which is a typed lambda calculus, and it really only has, 8 different syntactic forms in the language. There's variables, literals, applications, lambdas, lets, and then we got casts and coercions. And did I miss anything out? Case.
Okay.
So, and with these, 8 or 9 constructions, we just compile everything through that. So that means that all the optimization passes, the specializer and the optimizer and common side expression, they only have to deal with these 8 cases. So then the backend only has to deal with the 8 cases. So, and one of the things that I think that GHC is unusual about is that this language is statically typed itself. So right the way through from the front end, all the way through, which way are we going? All the way through to nearly the code generator, it's statically typed. Then the last little bit is untyped, right? But that is a long period of static typing, and we go through that actually slows the compiler down as we're carrying types a long way. But it does mean that it's a very big sanity check, right? So if a new front-end feature of the source language, if somebody says, can't you do this to the GHC steering committee, if this cannot be compiled to the existing intermediate language, which is very expressive, it's System F, right? It's a blooming expressive language. But if you can't put it through there, then we think very carefully. Right? So it's a kind of sanity check that says that despite all this wild, efflorescence of creativity and ideas and so forth up here, there is a core intellectual simplicity
I like that.
That is not just we try to maintain, it's actually imposed upon us by the data type that we're compiling into, right? So we can't escape it. At least
it's really nice.
So that I think has meant that GHC is the compiled code is well, I don't know. Does that make compiled code fast? I think we've spent.
It means you can optimize. It means you're doing one set of work that's repeated everywhere. I guess that's the.
Yes, and there's 20 years worth of optimization work that's gone into it. At the same time, there is more that can be done. GHC, for example, is not a whole program compiler, so I think you could do more with specialization. I don't think we've reached the limit of so compiling a high order functional programming language does carry some overheads.
Yeah.
Does carry some overheads, but I just think that they're entirely acceptable. That
Yeah.
if you think about what is really eating my lunch, it's usually the algorithm or the amount of data you're shuffling. It's not. I haven't come across many companies who said Haskell is just too slow for us.
Yeah.
Right?
I
They
feel like
sometimes say it takes too long to compile, but not the compile programs seem to be fast enough.
yeah, I feel like in the modern world, it's increasingly just data transfer between two servers that's actually the bottleneck of
Yeah, that's
anything,
right.
because
Yes.
the web is everything. Yeah.
Yes.
There's a lot of people asking around places Haskell is used in the real world. I think there's two interesting ones that jumped out in particular. One, someone asked if there's any if it's used in any particular security orientated environments. I guess because of things like it's strong type system, it has certain guarantees. So that question, and then also broadly, are any places that you've seen it that you've been particularly proud to see it running? Was the second question that I liked.
Well, for the first, I think the security guarantees really are important. I mean, a company like Galwa, John Launchbury's company, they now do lots of languages, but they were initially a Haskell company and still use a lot of Haskell. And that's because all their work is in the high assurance sector, right? All their work is about high assurance computing, when you really care about whether the program is going to give the right answer. I was with colleagues today from IOHK, which is the company that does the Cardano and the blockchain behind it.
Okay.
And there you really, really care about getting it right. So Duncan Coots is the CTO there, and he's a long-time Haskell expert, and he's been using software transactional memory and types to encode session types encoded into the Haskell type system. They heavily use Haskell type system to ensure that they're getting the security guarantees that they need. So yes, I do think it's finance people care about getting programs right. So I think wherever people care about that the program really is right, you can write plenty of buggy programs in Haskell, make no mistake, right? But it does give you a powerful lever, particularly maybe in conjunction with some of these proof assistants, which incidentally companies like OHK are using. They're doing formal proofs about their Haskell programs, and Galwa too. So what was all that about? That's a niche I think that functional programming in general will continue to be important.
Yeah. Cool.
Places I'm particularly proud to see it running. I don't know. I was quite excited when I learned that GitHub was using Haskell in their semantic analysis. And quite sad when they went through this same epiphany of, well, we've got 1 million lines of code in X and only 100,000 in Haskell, so we're probably not going to continue with that. That was quite frustrating. Quite moment. Lots of banks have little Haskell implants in them.
Okay. We've recently added both Fortran and COBOL tracks to Exercism, so you can now learn Fortran or COBOL in interactive environments. But maybe learning a bit of Haskell is better if you want to get involved in banking. I always think of Fortran and COBOL as the systems that have still got banking credentials.
Yes, they are. Yeah, they have a lot of legacy code to worry about.
Yeah. I think you can now, if you learn Fortran and COBOL now, you can earn a hell of a lot of money, because there are many people that can do it, and there's still a lot of very important code running in those things.
Very interesting. Some of the applications in finance came from a paper that again was directly inspired by Haskell, called what's called Composing Contracts was the name of the paper. Wrote with Jean-Marc Ibert. It was about describing financial derivatives as functional programs, right? In a little domain-specific language of combinators that describe derivatives. And this paper turned out to be it was. I don't think we would have written it had Jean-Marc, who is a finance expert, not and I not been working together, right?
Yeah.
But that sort of combination of expertise produced this thing, which then quite a lot of banks then have little clones of that set of ideas. It turns out it's been a very, but it's an example of the way in which functional programming can have an influence that it's not even on programming. It's how they think about their composing their financial derivatives.
Are there any particular programming languages that have excited you in recent times? Somebody specifically asked that about Unison. I don't know if you've come across Unison.
No, I have. I don't know enough about Unison to go sort of, but I think it's the one which has this idea that that every programming sort of exists for all time.
Yeah, your code is like a contract, basically, I think, and it's really interesting. It's something that I know Eric, out of all of the programming languages that he has explored, I think Unison is the one he's most excited about at the moment. But
So
yeah, are
Eric
there
is
any
the
others?
antithesis of me. So Eric, is can write 70 languages, and
Yeah.
I'm really only good at one or two, right? Because
Nice.
and it's a capacity thing. My brain is only I only have so many cycles, and so I think there are lots of other interesting languages. But to really say anything meaningful about other languages, you have to write code in them.
Yeah,
Um,
100%.
and,
Yeah.
and I've not done that very much about other languages. I just have respect for them typically.
Yeah. So there's a few more questions that I'll ask, and I'll just ask them as they're coming in.
Yeah.
So one is, what are your thoughts on lazy evaluation nowadays? Have those changed over time?
Oh, certainly changed over time. Yes. So
Okay.
initially, lazy evaluation was the rallying cry of
Okay.
Haskell. Right. That was what Haskell was about. It was all the guys who were doing, the research groups who were doing lazy functional programming got
Mhm.
together to design Haskell. So Haskell's high order bit was it's a lazy language.
Mhm.
But then I long since realized, given whole talks about this, that
Mhm.
the most important thing about laziness is that it forces purity.
Mm.
Right? Because in a lazy language, you can't afford to say print X somewhere in the middle of a computation. But
Mhm.
because if you have the list print X, print Y, will we print X before Y, or both,
Mhm.
or neither, or in the other order? Who knows? It all depends on
Mhm.
the consumer of the list.
Mhm.
That's insupportable. So what that means is you're not tempted to add side effects by the back door.
Mm.
So that meant for the first few years, Haskell didn't have any side effects. It was just it was your Haskell program was this function that took a string and produced a string. That
Yeah.
was all. And then it was a function that took a list of IO requests. No, took a list of IO responses and produced a list of IO requests. It's slightly
Mhm.
strange. But that was all before we invented monads. Um,
Mhm.
that was another Phil Wadler innovation. That was a real eye opener. But
Mhm.
where was I? Oh, that's right. What's important about laziness? So the important thing about
Mhm.
laziness was it meant we stayed pure. So
Mm.
I now think that GHC meanwhile has grown lots of strictness annotations. So
Mhm.
you can make your program a lot stricter by adding bangs all over the place.
Mhm.
And so in a way, GHC is moving like this, saying we want to be we start lazy and we are becoming stricter.
Mhm.
Strict languages tend to
Okay.
support laziness in some way. So we're
Yeah.
kind of clearly moving towards the middle. And I
Uh-huh.
sometimes joke that if we were designing Haskell again, I might make it strict, right?
Right.
But still pure, right?
Yeah.
But then I'd probably think, oh darn, I really miss that laziness, and the
Yeah.
grass is always greener on the other side of the
Mm.
fence. So I now think of laziness as not the high order bit, as
Okay.
just a beautiful feature of Haskell that I love very much, and
Mhm.
but also curse.
Yeah.
And often I envy my call by value colleagues because
Yeah.
they have things so easy.
Mhm. So is pureness now your higher order bit?
Purity is the high order bit.
Purity?
Yeah.
Yeah.
So
Yeah.
when I think about what influence is functional programming having on the world,
Mhm.
it is purity is
Yeah.
important.
Yeah.
So there was a paper that Pat Helland
Mhm.
wrote, and his title was the best paper title I've ever read.
Okay.
And the paper title is this: Immutability changes everything.
Excellent.
Great title.
Yeah.
Search for the paper. Um,
Yeah.
and his point was, look outside across systems.
Mhm.
Log-based file systems. They're just functional programs, right? In which you,
Mhm.
instead of mutating the file,
Mhm.
you're keeping a trail of diffs to the
Mhm.
file, and database updates are done like this, and
Mhm.
he says, accountants don't have erasers, right?
Okay.
You don't rub things out. You just add new things onto
Mhm.
the edge, and distributed distributed systems and replicated file stores do all this. So that once you start to look at the world through the spectacles of purity, you see
Mhm.
purity everywhere. Um,
Mm.
and you can see, and if you look at it, with rose tinted spectacles, you could see the influence of functional programming everywhere through that, right?
Mhm.
So I think functional programming is just saying immutability changes everything,
Mhm.
especially the act of writing a program.
Yeah.
And that is the gift that functional programming gives to the world, and it is a gift that Haskell, because it is lazy,
Mhm.
most quintessentially embodies, right? Because it
Mm.
has to be pure.
Mhm.
Um,
Yeah, that makes total sense. That's a lovely description. Um, Somebody asks, there's so many questions, I'm not going to get through them all, but I'm trying to choose ones that were sent to me before this in preparation because I promised I'd ask them. Somebody says there hasn't been much news lately around about progress towards adding dependent types to Haskell. Has progress slowed? Is there a kind of timeline we could expect to appear in GHC?
Oh, well, yes. There isn't one thing that is dependently typed programming, right? It's an enormous and complicated design space. And GHC is already in it, right? So GHC already has plenty of dependently typed features. You can do lots of computation at the type level. You can sort of reflect, with singleton types, you can reflect at the type level things that happen in the terms. There's at the other end of the spectrum, a sort of full spectrum dependently typed programming languages, which has no difference between types and terms. Right. So the marriage has gone completely, and that would be quite hard to achieve in Haskell. At an engineering level, it would be hard to achieve because GHC is a big old compiler now, and making types and terms be the same thing would be a big deal. And also because it's I'm quite keen for us to move Haskell in a way that keeps on board all of our existing user base, right? So there is a that the dependently typed programming can be I find it a bit mind bending, right? So I don't want to make it so that you can only use GHC if you're prepared to do the to be mind bended in that kind of way. So essentially, we're trying to move towards dependently typed programming like as a North Star, but a step at a time. So, and has progress slowed recently? Maybe. I think you should ask Richard Eisenberg or Stephanie Wyrick. I think they're happy with the way things are going. I do feel the last couple of years I've spent consolidating a lot of the progress that we've put in GHC, but that's made the code base a bit unstable. And then we get bug reports about this program doesn't type check or that doesn't work quite right. And so I've done a lot of consolidating and refactoring. I've just this week I've been refactoring the type checker again to try and make everything more solid. But I don't. Yes, there's. It would be interesting to know. Maybe the questioner can start a conversation on the Haskell discourse. With a there is a web page that describes a kind of vision for dependently typed Haskell. Actually, where is it? I'll send you the link afterwards. You can make notes, because that does give a kind of roadmap, a kind of plan. That isn't going the whole 9 yards, but it's not, as I say, it's a complicated space. So if your questioner has something in mind, then articulate the vision, right? And you can take everybody with you. Then I know it's an open source project.
Nice, yeah, good. I like it. A question as well that was asked from a university lecturer in France. So he asked how best to insert his students into industry. He says their training that he's giving them, I presume, focus on theoretical computer science, such as lambda calculus. But the real world, in inverted commas, industry standards are very object oriented. How does he sort of prepare them for the real world while also trying to give them that foundation? I don't know if there's a question that's easy to answer, but
no, it's not. And in some ways, I'm not a very good person to answer it because it's quite a long time since I've worked in a university. I suppose I'm.
Maybe is there a way to transition from learning the more theoretical stuff and using that as the basis for writing production code in like the real world, again, inverted commas?
So see, I don't think of Haskell as more theoretical. Right? So I suppose one thing I'd say is don't just study lambda calculus as an academic exercise. Write functional programs and interesting ones that do things. And that gives you something that you can show your potential employer, right? Because typically employers, they're interested in hiring smart people, and some of them, I think, use Haskell experience as they think if they're a Haskell programmer, they're probably pretty smart. But I'm sure there's no substitute for actually writing. Get down and write some Python code as well. And you need to know something about machine learning these days. I don't think you can. If you leave university after a sort of a mono diet of lambda calculus and theoretical computer science alone, then you probably are going to be less employable. and fair enough. It's reasonable to expect you devote some effort to encountering the world as it is.
Mhm.
Um, but
I guess as
what
well,
I'd like to do, if they've also got a sort of a sense of the the awesome beauty and elegance that exists within computer science, right?
Mhm.
So that you don't immediately get the danger is you get sort of sucked into the morass of detail
Mhm.
and compromise and hacking that you have to do to get things done in the real world. If you have the sense of those sunny uplands, right?
Mhm.
That can help you navigate in the morass, I think. And
Mhm.
so I think it'd be pity to leave university without that sense of truth and beauty.
Yeah.
But you need some of this practical stuff too, I
Yeah.
think. And I think
And I
it
guess
would.
as functional programming becomes more proliferant in whatever the word I'm trying to say is, in the real world,
Yes.
then I guess that also makes that transition easier because, you know,
Oh
the
yes, but people
production
people
code is less
they've heard
expensive.
of functional programming now. They say, "Oh yes,
Exactly. Yeah.
we know that functional programming is important. I'm glad that you
Yeah.
know something about it." So even managers would I think that knowledge of functional programming was in principle a good thing.
Yeah.
They probably want you to be expert in Python as well.
Yeah. 100%.
I think proliferant is rather a good word, even
Yeah, I
if
like
we've
that. I'm going to
invented it.
stick with
Yeah,
that.
it's
I'm
a
going
good
to
one. Yeah.
add that to my vocab. Two more questions from the community, and I've got one final one.
Hmm.
So someone said, "Is there a feature that you wish you had got into Haskell but you haven't?"
Oh, wish that I got in. I haven't. Well, so I'm in a privileged position that I can probably just until fairly recently. Nowadays, there's the GHC steering committee, which does
Yeah,
act as a sort of brake. But until fairly recently, I could just put it in if I thought it
yeah.
was cool. Um, and
Is there
um,
anything you didn't have time to do, maybe that you wished you had more time that you could dedicate 10 years to try and do one feature or something that
um,
never made it? The fact that you can't think of
yeah,
anything off the top of your head is
yeah.
a
Not
testament to a good
not
career. I think
Not
it's
immediately,
you
no.
don't have any regrets.
But it's also a testament to the fact that some people have a vast agenda laid out in front of them, things that
Mm,
they want to do. I've always tended to sort of more or less follow my nose. It's
mhm,
worked out quite well in the end, but
yeah,
that to treat the present hum of what's going on in GHC and Haskell as
mhm,
a prod
mhm,
towards what's research to do. Like a relatively recent paper I wrote about was about a better approach to overlap checking for pattern
mhm,
matching. There's quite a literature about that, but with Sebastian Graf, really smart guy that I work with quite a bit, we wrote what I think is a very interesting paper about. But the paper said this problem is too difficult just to hack. Right?
mm,
We couldn't figure out what to do, so we
mhm,
had to do you could call it theory, but certainly it was formalism. We had to sort of
mhm,
nail down a little intermediate language of sort of pattern matching mechanism that we could then that got realized, but it could
mm,
never have been realized without
mhm,
writing the paper. So that,
mhm.
but that was provoked by. Not by, oh, this is part of my grand research agenda for multiple years. It was provoked by, here's a problem.
Yeah, an itch to scratch. Yeah.
Yeah, yeah, that's
Um,
right.
Last question from the community. Putting your educator hat on,
Yeah.
what should we be teaching children to help them eventually think like programmers? So I think the question is not how should we teach computer science, but what are the core skills we should be giving to children to enable them to eventually learn to code well?
I wish I really knew the answer to that question,
Mhm,
because if I've learnt one thing about education, certainly sort of high school education, it is that it is complicated.
mhm,
Um, and it's complicated because it deals with a wide range of children, right?
mhm,
Very wide range of children, not just the self-selected ones who go to university. So it's a
mhm,
more complicated um, scene than university education, I think. But it has the huge benefit that it addresses all children, right? It's a
mhm,
huge lever on what to do. So what should we teach about computer science, about programming? So I think the um, I don't think I've got a technical answer, right?
mhm,
But I have got a sort of emotional one. I think that if we can just leave as many children as possible, I hesitate to say all,
mhm,
with some sense of just how exciting and
mm,
interesting and beautiful and full of creativity and
mhm,
innovation, and also sense of agency, right?
mhm,
That computing and computer science is, that will make them into good then they'll
mhm,
be, that's the motivation they need to become good programmers, right?
mhm,
But if they get turned off by, well, here's an academic approach to writing programming.
mm,
So when I say sense of agency, I mean that um, we use computers a lot,
Mhm.
but if they don't work, we're often a bit helpless, right?
Mhm.
So when you start to learn how computer science works, and particularly when you start to learn how to program,
Mhm.
then you have a sense of agency about it,
Mhm.
right? You could change something.
Mhm.
If Quiver doesn't put the text on the arrows in the right way when you're typesetting your paper, you can download the source code for Quiver
Mhm.
and jolly well change it until it
Mhm.
does, which
Mhm.
as Guy Steele did 2 weeks ago.
Yeah.
So that that sense of agency is something I would love to instill in our young
Mm.
people, because I think there's I want children to grow up with a sense that they can be the masters of
Mhm.
their fate, rather
Yeah.
than the victims of
Mhm.
a complicated and dysfunctional society, and that you know being good at computing, and particularly being a good programmer, can be a little component of that sense of
Mm.
agency.
Mhm.
And that combined with a sense of awe and beauty, and that's really exciting. I think I'm wildly aspirational about this. I think most kids couldn't care less about maths or computing,
Mhm.
and they're not going to see beauty. They're not going to see this beauty. But nevertheless, I'd like to have a go.
Yeah, 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 yeah. That makes total sense. I, I,
Inspiring
I,
them.
I started coding when I was 8, and I think I was fortunate because that was the first time I ever got a computer,
Yeah,
and I could play games or I could make games, and I found that making games was more fun than playing them, and it was that sense of agency of like I can play the game someone else has made, and yeah, that's fun, but actually I can also have my own 3D Starship Enterprise landing in a field with some bunnies running around and a
yeah,
magic thing I've hidden some, and I think that sense of agency is what then stuck with me for my whole life was actually I don't want to be limited to what other people have made. I want to make my
yeah,
own world. And I think that's why things like Minecraft are so popular,
yeah,
where you can make your own world. And I
yeah.
think I couldn't agree more. Like if we can teach people the fun of doing that. So
And teachers really have a big leverage here,
yeah,
and we all remember the teachers who changed our lives. I've described
100%.
some of them.
Yeah.
I still, uh, it was, I still remember a teacher teaching me binary.
Hmm.
Um, but he taught. I'll just tell you this story very quickly. It was he said. He said, Simon, go away for the holidays and think about this problem. There's a bank teller in a bank, and there's an irate customer who comes in daily
Hmm.
and asks for a sum of money in pounds, between one
Hmm.
and £1,000. But he's always in a hurry and
Hmm.
cross. So, and the bank teller eventually worked out that they could put sums of money in envelopes, and then
Hmm.
when the irate customer came in, they could just flick some envelopes across, one or two or 10, and satisfy, and that would be done, right? Didn't have to do lots of counting, right?
Hmm.
So, and his question was, what's in the envelopes?
Okay.
Okay. So I go home and I think, well, there's got to be an envelope with £1 in it.
Hmm.
And then what if he asked for £2? So I better have an envelope with £2.
Hmm.
Two envelopes with £1 would be a bit redundant, right?
Uh-huh.
But now I can do three. Good. Okay.
Yeah.
So now I need one with £4. So now I can do
Mhm.
five, six. So before I'd finished, I'd invented the binary number system, but I'd done it through the medium of this little problem this teacher had given me,
Mhm.
which I remember
Mhm.
55 years later.
Yeah.
So don't think that's an awesome, example of how influential a teacher
Yeah.
can be in a young person's life. So
100%.
hats off to teachers. Any teachers listening to this, I just love you to bits. And
Yeah.
please, I think the rest of us should do everything we can to be as supportive of our computing teachers as we
Mhm.
possibly can. Go find your local school, find who's the head of computer science, go and talk
Mhm.
to them, sit alongside them, don't tell them what to do. Say, how can I help you doing a
Mhm.
better job of inspiring our young people with computing? Because it
Mhm.
is the most exciting subject discipline in the world, and it will help them get a good job.
Yeah. I'm going to use this opportunity just to plug Exercism. We have free mentoring as part of Exercism. Hundreds of thousands of mentoring sessions have happened for free. So if you're watching this and you've not used Exercism, come onto Exercism, do some Haskell code, and some experienced Haskell developers will mentor you and help you to your heart's content, all
Yeah,
for free. So
great.
yeah, and a thank you to all of our mentors. So I'm going to ask you one more question, and then I'll let you go. I'm really grateful for your time, Simon. So back in 1999, you contributed to this book, Cybernauts Awake,
Yeah,
looking at the ethical and the spiritual implications of technology. It's been nearly 25 years since then.
yeah,
And we have AI and VR on the horizon, both of which I think are significantly change our interaction with what reality is, and changing reality from something that has been given or imposed on us into something we're much more creating ourselves. How do you feel that um, that those ethical and spiritual implications of this have evolved? Like, are you hopeful? Are you wary for people who are thinking about how to use their time over the next 25 years, ethically, and what should we be doing to try and make sure that we leave the world in a good place as these new realities do take hold?
Yeah, good question. So I participated in the group that wrote this book because I'm a Christian, because I think that life is about more than tech, and that I think all of us recognize that the world we live in and the society of which we are a part is is not going to function well unless we pay attention, right? If you like, the only thing necessary for evil to flourish is for good people to do nothing, right? So I think we are in the tech sector, we are willy-nilly at the epicenter of a lot of change, and the stuff that we build will affect people's lives in a pretty direct way, often in a good way, but not necessarily, right? There are many good things. Think about all the wonderful relationships that have been, developed and enhanced by Facebook, right? But also, then you've got to be anxious about the things that haven't gone so well. So I think for me, the big thing is we have to pay attention. That means all of us, right? Rather than just being, saying, well, other people can pay attention to that. I'll just sit in front of my screen and write my Haskell code. I think all of us need to. I'd love all of us to be involved in some way in trying to make sure that technology lands well. Now, what way that will be very different for all of us. I mean, I think just at the moment, all this AI stuff is, flavor of the month, and there is plenty to celebrate. I mean, it's ChatGPT is just an inflection point. It's just astonishing that 200 billion floating point numbers can do so much, right? That's only a terabyte. It's extraordinary. So, and that has lots of implications, but I think the implications are too important for us to just leave to other people. I think we have to play a role. So then, what kind of role can we play? Well, so I've sunk cycles into helping with education. I think other people might. I think most companies would probably like to think that they are doing good in the world, and would probably be open to some kind of group or thinking about what good looks like, right? We can be involved in in groups or thinking outside work too. I'm struggling to be very concrete about this. I think my big ask would just be, don't just sit there and assume that good things will happen. I think we all need to play an active role, and that does mean a political role in the best sense. But politics for me is the way in which large groups of people interact together to achieve common goals. Right? Politics is a very healthy, good thing. Right? And so some of us actually need to become politicians. I think there's a shameful lack of politicians in Parliament. But that's not going to be for everybody. But then, those people in turn need to be propped up by a pyramid of other people who are doing good things. Yeah. So just no, don't wash your hands of this. Tech people are implicated in good ways, but I think we need to be responsible for the things we do too. And that means paying attention and devoting some of our personal time to thinking about it and trying to help in some way. One way you can help is by giving money away, by the way. Yes. People in our sector tend to earn a lot of money, and I think we should just give lots of it away. And that all by itself can be transformative for the people you're giving it to.
I agree. And if you want to donate to Exercism and you're watching this, please do.
Yeah, that's right. Exercism is a doing good in the world kind of thing. Yeah. It is a non-profit, isn't it? Yeah. But somehow people in the tech sector are we are just it's like having won the lottery. We do something that we love, and we get paid lots of money for it. It's ridiculous, right? Other people do things they love, like school teachers, and get paid much less for it. That's weird, right? So I think there's another part of our responsibility. Yeah, just
wonderful.
Yeah.
Thank you so much, Simon. That's a really good note to end on. I've really, really enjoyed talking to you. I know people in the comments as well are just saying thank you very much, and
Great.
thank you for all you've done as well for Haskell and for computer science and programming in general. It's yeah,
Well, it's been a lot
career
of fun.
to
And the
go
wonderful thing about the the Haskell community in general and the computing community
yeah,
at large, the open source community, is that it's composed of a lot of very friendly and supportive people. So
yeah,
who I love working with.
yeah,
So all team effort, chaps.
yeah.
It's a team effort.
Well, thank you so much. I'm going to end this here. It's been a real privilege.
Yeah, great.
Thank you for your time.